Alright, in this next lesson we're going to learn about the Pythagorean Theorem. Now the Pythagorean Theorem is very real life and usable in the real world because it's something that has relationships to something that you can actually see. And so this one is actually pretty important. You'll use this a lot in geometry when you're working with triangles and rectangles and all other things like that. Now the Pythagorean Theorem relates to right triangles. Okay? And so you have to make sure that it is a right triangle before you use the Pythagorean theorem. A right triangle is a triangle that has a 90-degree angle. Okay? Sometimes it's shown with 90 degrees, but more often it's shown with that square mark there, showing that this is a right angle here. Now, the side that is not touching the right angle, so that's this one over here, that's always the longest side. That's called the hypotenuse. Okay, and that's always the longest. Now, the other two sides are both called legs. Okay, and these definitions will be important as you're reading some of the word problems and as you're trying to understand what's being described. And so you have the legs, you have the hypotenuse, and then there's always that right angle which doesn't touch the hypotenuse. It does touch both of the legs. Okay? Now the Pythagorean theorem is related to the legs and the hypotenuse. Now the legs we will refer to as side A and side B. Okay? Now it doesn't matter which leg is A and which leg is B, because they're both the same thing's gonna happen to both of them. The hypotenuse is always going to be side C. That's the longest side, and that's always the one that doesn't touch the right angle. The Pythagorean theorem says that for a right triangle, a squared plus b squared will always equal c squared. Okay, now this does not mean that a plus b equals c. Okay, it's a totally different relationship, that a squared plus b squared will equal c squared. A and b being the legs, and c being the length of the hypotenuse, which is the longest side. Okay, so what I'd like to do now is we're going to scroll down and we're going to look at a couple of examples using the Pythagorean theorem of a squared plus b squared equals c squared. Okay, the first problem here is that the lengths of the legs of a right triangle are 5 and 12. Find the length of the hypotenuse. Okay, so I'm going to go ahead and draw my triangle here. Right triangle. Now it tells me that the legs, now those are the sides that touch the right angle, are 5 and 12. Okay, so that's A and B. And it says find the length of the hypotenuse, that longest side which is C. Okay, so I'm going to go off on the side here, and I'm going to write a squared plus b squared equals c squared. Okay, now I know that a is 5, so 5 squared, plus b is 12, so that's 12 squared, will equal c squared. So 5 squared is 25, 12 squared is 144, that will equal c squared. 25 plus 144 is 169. And now I don't really care what c squared is. I want to know what c is. So how do I solve for c? Well, you're right. We do the inverse. We take the square root. And so the square root of 169 is 13. Now normally when we take the square root of a variable, we take the positive and negative answers. But in this case, the negative answer doesn't really mean anything because I can't have a negative length. And so I'm just going to take the positive answer. Alright, so there we go. A squared plus b squared equals c squared. Let's go ahead and look at one more example though before I scoot on to the next video. Okay, so this one says a right triangle has a hypotenuse of 7 centimeters. If one of the legs is 5 centimeters, then how long is the other leg? So we'll draw our right triangle. Okay, now it tells me the hypotenuse is 7. Now the hypotenuse is C, right? That's the longest side. So that's going to be 7. Okay? And then it says one of the legs is 5 centimeters. I don't really know which leg it is. It doesn't matter because I could flip the triangle around and look at it in some other direction. So I'm just going to say that A is 5 centimeters. That means that B, the other leg, is the one that I don't know. Okay? So when I write my equation, a squared plus b squared equals c squared, this time I have different numbers, right? And so I'm going to put the different numbers in. I've got a, so that's 5 squared, plus b squared equals c squared, and c is 7. So 7 squared. Now you'll notice if I had chosen to call 5b, then it would have been a squared plus 5 squared, which is the same thing. And so I'll get the same answer either way. 5 squared is 25, plus b squared equals 49. Now, of course, I want to get the b squared by itself, so I'll subtract the 25. We did this a couple of lessons ago, solving for a square term. And so 49 minus 25 is 24. I will take the square root of both sides because the square root and the squared will cancel each other out because they're inverses. So b equals the square root of 24. Now here's the hitch. If you end up with a radical, you should always simplify it. Okay? Now I know that 24 is equal to 4 times 6, right? Now the square root of 4 is 2, and then the square root of 6 will be left inside. And so that will be my final answer. Okay? Now, of course, you could plug this into your calculator. You could find out what that is as a decimal. Okay? As I'm working my examples, I will not do that. I'll leave it in the exact form as a radical because that's what most people tend to have a harder time with. You can always plug this into your calculator and type in the square root of 24 and find out exactly what that is as an approximation as a decimal. Okay, so now I invite you to go on to video number 2 and look at a couple more examples of word problems.